Excellent. Well, and we're at 3:40, so we should probably, we'll be timely. Excellent. Well, welcome. This is an overview of Kata Containers and also some information about getting started with Kata, using it, contributing to the community, a little bit about how we work and what we're about. I'm Bertucio. I work at the OpenStack Foundation, where one of the roles I have is being the community manager for Kata Containers. And with me is Samuel Ortiz. He's a principal at Intel. He's an integral part of the Clear Containers team and also on the Kata Architecture Committee. So he'll join me in just a moment. So Kata Containers. Kata is about producing the speed of containers with the security of VMs. We're going to dive into that, but before that, it's always kind of good to take a step back and talk about what is the problem we're even trying to solve. You know, there's no shortage of containers projects out there, so why did we decide to add another one? This is really, the problem here that we're looking at is the issue of the shared kernel in a traditional container architecture. Many of you are probably familiar with this setup. You know, containers A, B, and C all have that shared kernel. And if one is, container A is compromised, we now maybe have some vulnerabilities and some compromise in B and C. And so for people who are in highly regulated environments, enterprise grade, anyone who's risk averse for any reason, this doesn't really do it for them. So Kata Containers is about addressing that issue of the shared kernel. And so here, what we do is each container or pod is isolated through its own VM and its own kernel. These aren't full virtual machines and kernels, but rather it's a lightweight VM and a mini kernel, so there's minimal impact on the performance. We're still producing performant containers, but now we have that hardware-backed isolation between them. And here's a cute clip art slide just to drive the point home one more time. You know, virtual machines, great for isolation, runs like a tortoise. Traditional containers down at the bottom, great for speed, a little more risk. Kata Containers, we're up in the far quadrant there. That's what we're about. Kata is the merger of HyperSH's RunV technology and Intel Clear Containers. So in December, we made an announcement at the Austin KubeCon that we were intending to have this project. And the history really comes from both Hyper and Intel were looking at this problem with that shared kernel, and they were realizing they were coming to this similar solution. They're both ending up with these virtualized containers. So rather than work against each other, I thought, you know, let's open source this, we'll come together. And they donated the code to the OpenStack Foundation to be a vendor-neutral home for the governance. And just to iterate, because it can be a little bit confusing. So Kata is its own thing, completely separate from OpenStack, the project, as you might know it. If you're familiar with OpenStack, there's 60-some projects that live under that name. So there's compute, there's storage. Kata is not number 61. It's its completely own thing, different set of governance. We just share the same nonprofit home. And I'll let Samuel give a little talk about the technical vision.
Thanks, Anne. OK, so I'm going to talk a bit more about the technical details of Kata. But first, I want to ask a question. And there's some hoodies to win, so you better answer. Who knows here what is the main difference between Kata containers and a regular container? OK, so what's the answer? You run in virtual machine, yes. You just get yourself a hoodie. There you go. Thank you. Yes, that's the main difference. And the whole technical vision around Kata containers is about running a container inside a virtual machine. And by a virtual machine, we literally mean a virtual machine, which is a real full-blown virtual machine. So you might think this is very slow, big, bloated, and, well, what virtual machines are. And the technical vision around Kata containers is to make them light and fast. So we want the security advantages of virtual machines, but we don't want them to be bloated and slow and big. So that's the main point about Kata containers. Integration with the rest of the ecosystem is the second most important point. We really want Kata containers to work seamlessly. And by seamlessly, I mean that from a user perspective, you never notice that you're actually running on a virtual machine or on a regular container. You just can't tell. So we have seamless integration with Kubernetes at the CRI level. For those of you who are familiar with the container runtime interface. We also seamlessly integrate with Docker. So you can just change or specify which container runtime you want to use with Docker and say, I want to use Kata container, and start all your containers with, as virtual machines, again, seamlessly. Same for the networking, where we just use the regular CNI networking plugins. Nothing special there. We try to test with all the major networking plugins out there. We can test with the unknown ones, but so far we haven't hit any particular issue with the existing CNI plugins. We also provide a CRI-compatible API. So we both integrate at the OCI level, and I'll talk a little bit more about this, but also at the CRI level. So you can use Kata containers not only as a runtime, but also as a library. So you can implement your own Kubernetes CRI shim and call into the Kata container library to manage and create your containers as virtual machines. So you don't need to use the OCI binary that Kata containers provides to use the project. Last but not least, we support multiple architecture. I'm an Intel employee, but yeah, I want to make sure that everyone understands this is not an Intel-only project. It runs on other architectures. I won't name them, otherwise bad things can happen. It also supports multiple hypervisors. So our main focus is KVM, QEMU KVM, but the architecture of the project is done so that you can add your own hypervisor. So if you have your proprietary hypervisor somewhere in your cloud that is not QEMU or not KVM, then come talk to us, and we'll make sure you can integrate that. So that being said, there's a few interesting use cases for Kata containers. One of the first one is where you absolutely need to have the equivalent of virtual machine security for your container workloads. In some regulated environment, people actually don't have a choice. They either run virtual machine or they don't run. And if they want to go with containers, they need to have something like Kata containers. Another interesting one is, and I'll also talk about that a bit later, is that you can mix Kata containers and regular containers. As I said, it's completely transparent and seamless, so you can have your regular runC-based container together, running together with a Kata containers. So in environments where you basically throw trusted and untrusted workloads to your cluster, you have development workloads together with almost production-ready workloads, and you want to have them running next to each other, and then you can use something like Kata containers. And the one that you don't trust, you put them in a virtual machine, and they won't mess with the rest of your cluster. If you want to run a full multi-tenant Kubernetes cluster, Kata containers is probably a good solution. It doesn't implement the entire multi-tenancy for Kubernetes, but it will give you hard multi-tenancy for CPU, memory, and devices. So there are still some gaps for having a full multi-tenant container cluster, but it's a very good start. Bare metal, if you want to, and this is, as Anne was saying, Kata containers emerged between two projects, Hyper, runV, and Clay containers. And Hyper is a company actually providing a bare metal containers as a service offering. So when you go to hyper.sh, it uses Kata containers, and you will run your containers bare metal. So there's no VM created to host your Kubernetes nodes or anything like this. This runs directly on bare metal as virtual machines. That being said, bare metal is not a requirement for Kata containers. As long as your environment provides nested virtualization support, which most of the cloud providers do, you can run Kata containers. So bare metal is not a requirement. You can run Kata containers on bare metal. You can run Kata containers inside virtual machine as nested virtual machines. And finally, an interesting use case for Kata containers is where you absolutely need some very specific kernel features, or you need to tune some very specific kernel knobs, your TCP stack, or you need this proprietary kernel module. Not that I encourage writing proprietary kernel modules, but if you need one, Then with Kata containers, you can actually have your own dedicated kernel inside your virtual machine. So if you're a VNF provider or deployer, and you need very specific kernel modules to be installed at runtime when you start your containers, you don't want to do that on your host kernel. Actually, you probably can't do that on your host kernel, but you will be able to do that on your Kata container environment because, well, you have access to your own dedicated kernel. One use case that I want to highlight, I just talked about, is multi-tenant Kubernetes. And again, with Kata containers, you will not get a full multi-tenant Kubernetes, but it will get you there. I'm repeating myself, but it basically gives you real hard multi-tenancy for sharing CPU, memory, and devices across different tenants. So typically, as of today, if you want to run a safe multi-tenant Kubernetes environment, you will have to create a cluster per tenant. You want to have your tenants separated through VMs at least, or well, maybe you don't, but yeah, do that at your own risk. So typically, you will create several Kubernetes clusters through several virtual machines, each one representing a nodes per tenant. And the way you can do that with Kata containers is by having one single Kubernetes cluster. And with Kata containers, all your workloads will be separated the same way they are separated on the picture on the left, because they will be running on full-blown virtual machines. So you can have your tenant workloads working next to each other and have the same isolation guarantees that you used to have with separate Kubernetes clusters running on different VMs. OK, components. I'm going to go through a few of the components that make the Kata container project. So we have a few of them running on the host, and we have a few of them running on the guest. Again, your container is going to run in a virtual machine. The most interesting one on the guest is the agent. So it's basically the component that's going to run your container lifecycle inside the virtual machine. And as a matter of fact, our agent implementation is based on libcontainer. For those of you familiar with the runC project, libcontainer is the foundation library for runC, runC being the de facto container runtime. So inside the virtual machine that runs your Kata container, you will have an agent that looks like a very trimmed down runC. So you can apply all the OCI specification settings inside the virtual machine, so that when you run your container inside your virtual machine, it actually runs exactly the same way as it would run outside the virtual machine in a regular containerized environment. So that's very important from a security perspective as well, because you can monitor Kata containers the same way you monitor regular containers. If you apply the same seccomp filter inside a virtual machine as outside the virtual machine, you will see the same behavior. So if one of your workload is trying to call into a syscall that is not supposed to be calling in, you will see that with Kata containers the same way you see that with a regular container today. And you can kill it. Proxy. Optionally, we need a proxy. So the proxy is a component that runs on the host. Maybe actually, yeah, that's actually better. So the proxy runs on the host, and we need a proxy, but it's optional. I'll get that on the next slide. We need a proxy because we typically run the agent. The communication between the agent on the guest and the host is going through a serial port. So we have one serial port for each and every process inside your virtual machine. So if you have 3 containers running inside your pod, you're going to have all your I/O going through one virtualized serial port. And don't be scared with the serial port. A virtual serial port is fast. It's not your old 232 physical serial port, so it's fast, but it's still something that needs to be multiplexed and demultiplexed somewhere. And we do that through the proxy. We need a few shims, well, not actually a few shims, but one shim per process running inside a Kata container. Why do we need a shim? There's already a few shims in the container ecosystem for containerd and so on. But we need an additional one because the components running on top of Kata containers usually assume that they're going to talk to a process. And this process is your container process. In our case, it's not talking to a process, it's talking to a virtual machine. So we need a shim, and the shim is basically a translation layer between whatever we receive or we want to forward to the ecosystem on top of Kata containers, Docker, Kubernetes, OpenStack. Translate that between the agent command and process semantics. So when you want to send a signal to your container process from your kube control, we're going to receive a signal, but you're not going to signal your virtual machine. You want to signal something that's running inside your virtual machine. So you need to translate that signal into a command that the agent is going to be able to understand. I hope that makes sense. As I said, optionally, we can run without the proxy. And in that case, we use a fairly recent kernel feature that's called vsock. It's an implementation of VMware virtualized socket. So with vsock, you get sockets that are virtualized, and you can basically use the socket semantics inside and outside your virtual machine, and you don't need any multiplexer on the host to demultiplex and multiplex your I/O. You just have a socket semantics. So in that case, we simplify the whole thing and remove the proxy. I'm just going to finish my technical part, sorry, Anne. Talking about how we integrate Kata containers with the rest of the ecosystem, and in that case, with Kubernetes. I assume some of you are familiar with Cryo. Who knows Cryo in this room? Yeah? Well, I don't have enough UDIs, sorry. So Cryo is just one example of how we integrate Kata containers with Kubernetes. You would have pretty much exactly the same picture with Containerd today. And again, this is just an example. So when you run your Kubernetes workload today with Cryo, you have kubelet talking into the CRI, and then the CRI talking into the CRI shim can be Cryo or Containerd or anything else. In the Cryo and Containerd cases, they assume that they're going to have a OCI-compatible runtime below it to actually translate the CRI commands and specification into actual container lifecycle commands: run, start, stop, exec, and so on. And so they just call into runc to execute those commands. Kata containers is an OCI-compatible runtime. And so you can literally replace runc with Kata containers, and Cryo or Containerd will talk directly to the Kata container runtime, binary runtime. And instead of creating namespace-based containers, we will have virtual machine created for you. So I want to insist on the fact that this is A, fully transparent and seamless. So you just literally replace runc. And B, that you can mix workloads together. And that example is a practical one. We do that in production where you have runc running regular containers and Kata containers running more secure containers. So this is very important and a very nice feature from Kata. And I'm going to hand the mic over back to Anne now.
OK, so I'm going to go kind of quickly through a couple of these things about contributions and how we work in the community, just because I want to make sure to leave time for Q&A and more hoodies, the important things. So we are aiming for a 1.0 release end of May. We're aiming for May 22nd. So where we are right now, clear containers and runv have been merged into a single implementation. We've surpassed the capabilities of Clear Containers 3.0, which came out in January, and we're pretty darn close to parity with runv at this point. For the release, we'll have those CRI integrations that Samuel was talking about, as well as some documented upgrade paths for existing runv and Clear Containers users. If you want to give Kata a try, you can try what we have right now. It's on our GitHub in the documentation repo. There's some documentation about the limitations and some caveats, but it's up there. I see a few phones, so maybe I'll pause for a second if people want that URL. Excellent. But if you're interested in contributing, we would love to have you. You can read the contributor guide on the GitHub. It's in the community repo. And this is a Kubernetes crowd, presumably, so you're probably familiar with Go, projects written in Go, and the Apache 2.0 license is our open source license. So same as Kubernetes. One thing we do that some people have not had experience with before is that we use signed off by from the Linux kernel community. In the contributor guide, there's some information about that. If you haven't experienced that before, I'd encourage you to just read through it carefully. I would hate for PR to just sit and fail because you missed a little bit of the formatting on that one. So just something to call out and pay attention to. When you get to the Kata Containers GitHub, you will see that we use the help wanted and good first issue labels. Other areas that we're really looking for some extra hands are in tests and docs. So if testing or documentation speak to your heart, we'd love to have you. There's a test repo, docs, we're looking for reviewers, and editors. If you think Kata Containers is going to be the right solution for you, but there's something specific to your use case that you're thinking of that we don't seem to have covered yet, or maybe you think you're a corner case of some sort, please use a GitHub issue to file a feature request or drop into one of our community communication channels and talk to us about it. We want to make sure we're meeting everyone's needs here. If upstream code is not your thing, community engagement, we're definitely looking for people to kind of spread the good word of secure containers. If you are a meetup organizer, we're happy to have someone come talk about Kata at your meetup. If you like to make blogs, demos, there's no shortage of work to be done if you're interested. We are doing some community planning at the end of this month at the OpenStack Summit in Vancouver, BC, May 21st through 24th. We'll be organizing for the 1.1 release and onwards, and also thinking about how we work as a community, what we want basically our community to look like. This is ours to build together however we think it should be built. So if you're interested in that, you can drop by and register. It's openstack.org/summit/Vancouver-2018. And this is some information about where we hang out. Like I said, we do use GitHub. So you'll see github.com/kata-containers. Our communication channels are IRC with a bridge to Slack. So you can kind of pick your poison, depending on what you like. We have a developer channel, kata-dev, and then just the general inquiries is under kata-general. If you do like Slack, that bit.ly will take you directly to the invite, so you kind of bypass that stalled page there. If you like to tweet, we have @Kata Containers, and our developer mailing lists you can subscribe at lists.katacontainers.io. So all of this is also on katacontainers.io. You can find out more information there. Sorry, again, a couple phones, so I don't want to dash off if people want a photo of our communication channels. But with that, we have about 10 minutes or so for some Q&A, and I think that's probably the most important part, is how we get your questions answered. Yeah?
So one of the things that used to be a pain with VMs is that you have to size them up before you start them, like give it 1 GB of memory and so on. Did you solve this, or are you trying to solve it by demand allocating memory or disk and so on?
I'll let Samuel answer that one.
So we do CPU, memory, and networking hot plug all the way through. So based on the demands from the workload, we can add CPUs and add more memory, basically on demand. Yeah, but it's not an easy problem to solve. Let me put it this way, especially for memory. Yep. Oh, this gentleman was first. Yeah.
Yeah, so what's the typical overhead that you pay for using the isolation? And the second question is, can you actually expose host parts or GPU devices at this point? Or is that in the roadmap?
So the overhead is actually, it's not a binary answer where you can say we use 30 megs of memory overhead. We use all sorts of techniques for deduplicating memory, reducing memory consumption. And what we realize for memory, for example, is that when you run very small workloads, the overhead is there. So compared to regular containers, you do see a memory overhead. But when we start running, the bigger the workload, the smaller the overhead. Because with Kata containers, you can actually deduplicate pages across different VMs or containers, whatever you want to call it. So if you run 10 different instances of Elasticsearch, for example, you will see a memory overhead that's more interesting with Kata containers than with regular containers. Because if you run 10 different containers that are running Elasticsearch, which is a very big workload, we're going to aggressively deduplicate memory across those 10 different containers, whereas with your regular containers, you're going to have a lot of memory duplication. So with big workloads, the overhead is better with Kata containers than with regular containers. There's a CPU overhead that is the least of our concern, to be honest with you. The VT or the AMD instruction sets are done so that the virtualization overhead is very small. Nested is another story. Nested, the CPU overhead in nested is not that bad. What's really ugly in nesting environment is memory overhead, and the worst case that you can hit with in nesting environment is page fault. So when you do page fault, you enter a quadratic algorithm to feed your pages back into the page tables, and this is very heavy. So nesting has its own set of overheads that are highly dependent on the kind of workload that you're doing. So if it's a very noisy workload that trashes your TLB and goes constantly across your memory address space, then yes, in nesting environment it's not very good. But usually those workloads are not. Yeah, you don't want to have those workloads anyway. So, was that yeah? More questions? Oh, sorry. Yes, the host path on GPUs. Yeah. So we don't mount the host path per se. We do something much more secure. We do device assignment. So that's another advantage of Kata containers, where you can basically do direct device assignment in a safe way by using stuff like VTD, IOMMU. Where you can assign your GPU or your networking card or whatever PCI or even non-PCI devices you want to assign to your container, and you can do that in a safe way inside a virtual machine, as opposed to just mounting your /dev into your container. There was some question there. Sorry.
It picks it up at the same page. So shared storage, containers not having the means of mounting an iSCSI volume, and how do you represent that inside Kubernetes?
So for storage, we can do. Are you talking about volumes? Okay. So for volumes, we can either do block-based volumes, in which case you get a pretty nice setup. If you can do that, then we go through something called 9PFS. I'm not sure you're familiar with this. It's a basically Vertio file system. Let me put it this way, which is less performant than doing a block-based device assignment into the virtual machine. But when you don't have full control over your host environment, this is the only solution left, basically.
So QEMU is getting fairly old and perhaps a little bloated. QEMU is getting fairly old and perhaps a little bloated. Have you been looking at, say, KVM tool or similar kind of from scratch hypervisors?
So there's a lot to say about. There's a lot to say about QEMU, and yes, it's. I think QEMU is 3 million lines of code. So basically, when you run your regular virtual machine, your VMM is a quarter of the kernel size. So yeah, that's a little scary. To be fair to QEMU, if you configure it properly, out of those 3 million lines of code, you probably end up running 300,000 or 400,000. So we've been. I mean, as I said, our main focus is KVM QEMU because, well, this is, as much as people hate QEMU, it's the most tested and the most performant in terms of I/O VMM implementation out there. So that's what people use in production when they don't have their own hypervisor. But again, in Kata Containers, we implement each hypervisor support as a plugin. So if you're running your own private cloud and you have your own hypervisor, and you don't even want to have that as a public implementation inside Kata Containers, you can just implement your plugin for Kata Containers for your specific hypervisor. And I know some people are looking at this and maybe running that already. We just don't know about it. But the architecture is there specifically for that use case. This gentleman was first.
This is going to sound weird, but in a traditional container security world, you deploy like control groups and AppArmor and everything to the kernel. Do you need to do that inside the Kata container? Would you bother, or is the segregation of the VM enough?
So I quickly touched on this, and if you ask me, the VM segregation is enough. But we also found some customers and use case that were using tools that were actually monitoring these kind of things with their regular containers. So they were willing to know if a container was trying to get out of the AppArmor or SLinux context, or trying to call into a syscall that was not part of the seccomp filters. And they're willing to kill those containers that are misbehaving. So we realized it was actually useful to provide the same kind of filtering inside the virtual machine. So when you run Kata container inside your virtual machine, you have the VM segregation, plus all the filtering and security context that you can add to regular containers, especially for this kind of use cases, where you want to have very similar behavior when you run your containers as Kata containers or as regular containers. So to me, it's not a real interesting security added value, but it's just for parity between the two implementations.
So I have a question about storage. Do Kata containers have a concept like storage pools or providers, or they can differentiate about storage types and stuff like that, if you use them as standalone containers?
Yeah. So there's. Oh, you mean the overlay, the overlay driver? Yeah. We basically use whatever people set their Kubernetes or Docker engine with. So if you want to use a device mapper, you can use device mapper. If you want to use overlay 2, we're going to use overlay 2. It doesn't. It does have an impact. So when you use a block-based device overlay driver, you will get much better performance, because we can literally use VirtIO SCSI or VirtIO block to pass that to the virtual machine. If you use other overlay drivers, then we're going to use 9PFS, which is less performant. So depending, if you can control your environment, then we strongly advise for using block-based device overlay drivers. And we're actually building a reference implementation of Kata containers with all the best settings that you can use. If you provided that you can control entirely your host environment, what would be the best choice for running the most performance Kata container?
I think, Samuel, this will have to be our last question with time.
Okay. So you said before that the Kata containers are running inside the full-blown virtual machine. And this comes with restrictions that you have to allocate CPU cores, memory, storage, and stuff. So why, for example, should I use Kata containers instead of having a virtual machine that's inside? I have a operating system where I can run Docker or whatever. What are the pros and the cons in that case?
So the main pro for Kata container is that it's seen as a container by all the other components on top of it. If you run Docker, the Docker engine inside your virtual machine, you enter a completely different architecture where you have to have, for example, Kubernetes being able to talk inside your virtual machine to your Docker engine, and your Docker engine would launch your container. So you're basically back to a kind of regular setup, whereas with Kata containers, the virtual machine behaves exactly as a container. So you talk to Kata containers, the virtual machine, exactly the same way as you would talk to a container. So you don't need to have specific setups or specific architecture for using Kata containers inside your Kubernetes cluster. You just launch them as regular containers, and you can specify if you want the isolation layer to be namespace-based or hardware virtualized. That's the only thing you have to do. You don't need to set everything up besides that. If you run your Docker engine inside your virtual machine, you will need to do a lot of different setups to make it work. And so, no more questions?
Yeah, unfortunately, we are out of time.
Okay.
We have some one-pagers that kind of summarize what we talked about. Hoodie stickers, we'll stick around for a second.
And hoodies.
Yeah, hoodies.
Thank you.
Thank you for coming.